Good morning, everyone. So, welcome to organic chemistry, that is amine class. Uh, Yesterday, we have completed nitroalkanes and nitro compounds. So, first are nitroalkanes, second one is amines. Okay, so this is amines, and let's see the nomenclature how we name the amines. So, first, what is a functional group? What is the formula of functional group of amines? So generally the alkyl part which is connected with NH2 group, that is known as amines. Any alkyl part. So any alkyl part. So alkyl part we denote as R, and if it is connected to NH2 then it is considered as amines. Okay. And so amines are nothing but derivatives of ammonia. So this is NH3. So in ammonia, one of hydrogen is replaced with alkyl part. So alkyl part is replaced with whom? Hydrogen. So that results what? Amines. So again, the nomenclature, how we name the amines. So generally we name the amines. If you recall the IUPAC nomenclature, in that IUPAC nomenclature we use three words. One is prefix, second one is root word, and third one is suffix. So this root word indicates about the number of carbon atoms present in selected longest carbon chain. So prefix always denotes or indicates about the nature of substitution. And next come to suffix. Again we have two types of suffix. One is primary suffix, second one is secondary suffix. The primary suffix tells about whether it is saturate or alkyl chain or unsaturated. If it is unsaturated, that means whether it has double bond or triple bond. So in saturate, all carbon atoms of a longest carbon chain are skeleton connected through a single bond. So then the suffix becomes as "-ane". So in case of double bond, "-ene", in case of triple bond, that is "-ine". And the secondary suffix indicates about the functional group. So it indicates about the functional groups. So here our functional group is NH2. So what is the name of NH2? So amines. Methane amine, alkyl amine, like that. Okay. So let's see the first one. Okay. So first one is this one. Okay, so this is CH3NH2. So this is what? Methyl amine. So this is general nomenclature, that is methyl amine, and IUPAC, according to IUPAC, this is methane amine, methane amine, ether amine. So this is two. Okay, so I will show you. So CH3NH2. So here root word is meth, and when we have single bond then that is we use "-ane", and here the "-ane", last letter of E, that is last letter of "-ane", that is E, will be replaced with amine. So that is name of functional group. So as a whole we can write as methane amine. In case of this one, next one, this is CH3 CH2 NH2. So here we have how many carbon atoms? Two. So then root word is "eth", and these two carbon atoms are connected through a single bond. Then that is "-ane", and last letter will be replaced with amine. And next one more example, that is CH3 CH, and this is CH3 isopropyl, or you can say isobutyl if we add one more carbon atom. So in this case, this one is our longest carbon chain, that will be our root word, and this is substitution, and the name of that substitution is methyl, and this one is our functional group. The name of our functional group is amine. So how we write root word, that is prop, and next primary suffix is all carbon atoms are connected through a single bond, so then that is "-ane". So now, so this E will be replaced with amine. So this is about the name of one part. And here see, so what about the substitution? So always a substitution name comes beginning, that is methyl, and to which carbon atom this methyl group is connected. So we don't know whether it is connected to, if in this case we can't say that it is connected to first carbon atom or second carbon atom, whatever it may be. whatever it may be. So in this case, sorry. Okay. So here, so whether it is connected to first carbon or which carbon, we can't say this carbon or this carbon. So we can write any either of this structure or this structure for this name, methyl propyl propylamine. So if we mention the number of substituted carbon or to which the substitution is connected to, so that means the numbering. How we start the numbering? So we have two possibilities from this is left to right and right to left. So which one is correct? So this one is correct. So according to least sum rule, okay, the substituted carbon gets less number. So according to that, so first will be the correct one. So we can write as 1 methyl, this one methyl, remaining is same, propylamine, propylamine. So in this case, the numbering should be started from here. That is 1, and this is 2, and this is 3. Okay, so the name of this compound is 2-methyl. So that means our nomenclature should tell which carbon our substitution is attached. Okay, so this is about the nomenclature. So we have discussed earlier in our previous classes. So this is about the nomenclature, and this is cyclic amines as well as we have aromatic amines also. Okay, so this is aromatic amine. So if you see the classification, so we can classify the amines. We can classify the amines as this one. Open chain. So generally those are known as aliphatic amines, and cyclic amines are closed, whatever it may be. So again, this cyclic amines two types. So that is alicyclic. So that means it may not it may not follow the Huckel rule, and aromatic amines. So in aromatic amines, what we have? We have a cycle. So this cycle obeys Huckel's rule. So this is aniline. So general name of the compound is aniline, or generally we say methylamine. Sorry, benzylamine, phenylamine, not benzylamine, phenylamine. So this is alicyclic. Alicyclic in that we don't have any what we say. It may or may not contain multiple bonds. So if it is doesn't contain multiple bonds, this we can say saturated alicyclic. So this is cyclohexane amine. Cyclohexane amine. Okay. So this is about the classification of amines. Okay. So this is aliphatic, and these are aliphatic amines. So this is alicyclic, and this is aromatic amines. Okay. So here the substitution in the second case, the substitution is attached to which one? Carbon atom. So if you see the classification uh, in terms of, so this is one type of classification, and second one is we can classify the amines as primary, secondary, tertiary amines. Okay, even quaternary amines also. Uh, so I will show you how we can write, how we can classify the amines into primary, secondary. So all amines are what? Derivatives of ammonia. So this is ammonia. So if one hydrogen of ammonia is replaced with alkyl part, means it may be, yes, it may be a carbon, single carbon. So I'm showing this one, single carbon or carbon chain, whatever it may be. And we can write this one as R also, no problem. So this is primary amine. So that means if nitrogen is directly attached to one carbon atom, then that amine is known as primary amine. For suppose if two hydrogens of ammonia are replaced with two alkyl parts, then that is secondary amine. If three hydrogens of ammonia are replaced with three alkyl parts, that is known as tertiary. So this is primary, this is secondary, this is tertiary. And at the same time, in on nitrogen atom we have one lone pair of electrons. If these lone pair of electrons the lone pair of electrons are substituted with any alkyl part, then we may get this one. So here it get positive charge. Okay, so that means what? So here I am writing. Okay. So now the nitrogen is surrounded by how many? Four alkyl parts. And it possesses what? A positive charge. So this is known as ammonium ion. So in general terms, we say if we have all alkyl parts are replaced with hydrogens, then we represent or generally we term that one as ammonium ion. But it is what? Quaternary amine. This is quaternary amine. So amines are classified into four categories. First one is what? Primary, second one secondary, tertiary, and quaternary amines. So this is the classification of amines. And next move on to second one. So here see, this is the classification. This is primary, secondary, and tertiary, and this is quaternary. uh, Quaternary. Okay. So tetramethyl, this is quaternary, primary, tertiary, quaternary. And here these are primary, secondary, tertiary. This is quaternary type, but here we have only one alkyl part. That's why we are terming that one as one primary. This is secondary ammonium ion, tertiary ammonium ion. This is quaternary ammonium ion. Okay. And next cyclic. This is cyclic, and these are aromatic. And we consider this one as aromatic cycle. Why? Because this cycle is composed with other than carbon atom. So the other than carbon atom generally considered as heteroatoms. So nitrogen, oxygen, sulfur, phosphorus, all these are considered as heteroatoms. So that's why these structures or these compounds are known as heterocyclic compound. This is pyrrole, this is pyridine. Okay, next, this is the structure. So nitrogen undergoes sp3 hybridization, and what is the structure? Pyramid. Actually, we are expecting one tetrahedral, but due to presence of this lone pair of electrons, what happens? Distortion takes places. This tertiary amine, the quarter tetrahedral shape. Okay, I will show you in picture. Okay, so actually sp3 hybridization is tetrahedral. So tetrahedral means this is nitrogen atom. So we should expecting like this. But what happens here? This bond is replaced with what? Lone pair of electrons. So due to lone pair of electrons, so lone pair of electrons, what happens? Non-bonding. Vespar theory. If you recall Vespar theory, you have studied in intermediate first year, and ionic chemical bonding. In that Vespar theory, we have two types of bond pair of two types of pair of electrons, non-bonding non-bonding pair of electron, and second one is bonding pair of electron. So between these two, bonding or non-bonding, between non-bonding and non-bonding, and between bonding and non-bonding, and bonding and bonding, so we can expect three types of repulsions. So that will be discussed, is discussed in the Vespar theory, valence shell electron pair repulsion theory. In that, the repulsions is somewhat higher. The repulsions between the bonding pair of electrons, these are bond pair of electrons, and this is non-bonding electrons. So non-bonding and bond pair of electron, between these two, what happens? Repulsions takes places. Due to that repulsions, the tetrahedral shape is changed into pyramidal. So when it is changed into pyramidal, or you can say distortion, so due to that distortion or change in structure, it gains the stability. If it is present in tetrahedral, then what happens? It may experience some repulsions. Due to repulsions, it may lose the stability. So to overcome that, it changed its shape from tetrahedral to pyramidal. Okay, so that's why here he shown the large balloon. So that balloon represents what? Lone pair of electrons. The non-bonding electrons, or you can say lone pair of electrons. These lone pair of electrons occupy more space on nitrogen atom. So this is the one of interconversion. That means flipping. Okay, and next this is about the quaternary ammonium ion. So here this quaternary ammonium ion, it is wedge projection. In that wedge projection we have three types of bonds. This is a dotted bond, this is thick bond, these are normal bonds. Normal bonds are considered as in plane bonds, thick bond is considered as above the plane, this dotted line or broken bond is considered as below the plane. So this is quaternary ammonium ion, this is its mirror image. Okay, and synthesis, how we can prepare amines. Next important topic, preparations. So in our syllabus we have various preparative methods. In that, few methods he mentioned in our syllabus. So that's the first one is alkylation of ammonia. So alkylation of ammonia is nothing but what, replacement or substitution of hydrogen atom with, so this is the substitution of this hydrogen atom with whom, alkyl part. So that is known as alkylation. Okay. So how it's, when ammonia is treated with alkyl halide, when ammonia is treated with alkyl halide, what happens due to presence of this lone pair of electron, those are attacked on alkyl part, and thereby this bond completely shifted on or migrated on as halide. So X, so thereby it becomes as X minus. At the same time, when it donates its lone pair of electrons to alkyl part, it acquires the positive charge. And this part is known as primary alkyl ammonium ion. And this is X minus. Minus will form ionic bond with plus. So this is nothing but a salt. On hydrolysis, acidic hydrolysis, what happened? This salt will be converted into amines. Sorry, only on hydrolysis or when it is treated with base. So this is alkylation. This is single alkylation, mono alkylation. Okay, so here he instead of alkyl part he taken as ethyl bromide. So whenever ethyl bromide is treated with ammonia, we get what, ethyl amine, ethyl amine. Okay. So next one is this is mono alkylation. It is what, mono alkylation. Okay, using an excess of ammonia, which helps to minimize the multiplication of multiple alkylation. So that means, for example, if you see, I will show you. So what he means or what he want to tell you, multiple alkylation. So that means when this ammonia lone pair of electrons reacted with the alkyl part. So what happens? This lone pair of electrons comes here, and it will be removed as, so NH3, it will get positive charge and it will be removed as X minus and it will form an ionic bond. So in presence of base, what happens are basic hydrolysis, we get basic hydrolysis, not acidic hydrolysis, amine. So this amine, if the alkyl part concentration is higher, if alkyl halides are high proportion, are in high proportion, or we can say excess, then what happens? This alkyl amine further react with one more alkyl halide. So thereby what we get? We get secondary amine. And further this secondary amine is more basic, so that's why it again reacts with one more alkyl halide and we get tertiary. So tertiary amines are more basic, and that means we can say this alkyl part, this nitrogen has more. These are plus I groups. So this plus I group pumps the electrons. So thereby electron density on alkyl nitrogen atom, it increases. So it happens only in gas state. So again it further reacts with one more alkyl halide. Thereby we can get it quaternary ammonium ion. So that means when we have taken excess of alkyl halide, we end up with one formation of quaternary ammonium salt. When in the case of excess of alkyl halide, if we reverse the case, so reverse means if we take excess of ammonia, if we take excess of ammonia, so then what happens? These steps multiple alkylation may not take places and we will end up with primary amines. We will end up with only primary amines when we have excess of ammonia. Excess of ammonia. Only this reaction will take places. And so this is basic hydrolysis. This is basic hydrolysis. So basic hydrolysis will provide or produce our amines, desired one. So this is um, alkylation of ammonia. Alkylation of ammonia. So excess of ammonia helps to minimize the multiple alkylation. Okay, second one is very important, that is Gabriel Thalamide synthesis. So how this name uh, uh, comes to this reaction? So why this reaction is termed as thalamide? Thalamide. Okay, so let's see. So what is the name of this reaction? Gabriel Thalamide reaction. Gabriel Thalamide. Gabriel Gabriel Thalamide. So what is thalamide? So thalamide is nothing but a aromatic carboxylic acid, dicarboxylic acid. This is benzoic acid. If it is attached one more carboxylic acid, this is known as phthalic acid. This is what phthalic acid. And heating, upon heating or when it is treated with an anhydrating agent, then we get phthalic anhydride. What we get? We get phthalic anhydride. So this is phthalic anhydride. When this phthalic anhydride or else this phthalic acid is treated with ammonia, or you can treat with amine also, no problem, whatever it may be. So it will be treated with which one? Phthalic acid, either phthalic acid or anhydride. So if these two are treated with ammonia, then what happens? Removal of water molecule takes place, and we may get this one, amide, thalamide. So this thalamide. When this thalamide is further treated with base, so what happens? Base will take up one this hydrogen. So thereby we may get a potassium thalamide. So we get what? Potassium thalamide, N minus and K plus. So this is known as potassium thalamide. So this is our starting material in this synthesis. Okay, so let's see. So this is thalamide, and this thalamide is treated with potassium hydroxide. What we get? We get a thalamide, potassium thalamide, and this potassium thalamide. The next step, further this potassium thalamide is treated with alkyl halide. So then what happens? This negative charge attacks with the alkyl part, and thereby we get this one, N alkyl or N substituted thalamide. N alkyl substituted thalamide. And next, upon this acidic hydrolysis, what happens? Here, see, these two bonds will be broken. So this part will get OH, and this part will get OH, and this will H OH. So thereby again we get what? So phthalic acid. So we get phthalic acid along with our desired one, that is what? RNH2, primary amines. So by this method we can prepare only primary amines. So this is exclusively for preparation of primary amines. Okay, let's see. So this is step 1, step 2, step 3. Okay, so here I shown in direct step, but actually we can show these two steps also. So that depends upon you. Okay, here the optimization of cycle, the amide, this generally we say lactamides. So cyclic amides are also known as lactamides. So cyclic ring opening will take places, and then this will happen again. Cyclization takes places, but as a whole, our outcome is our desired product. And the next one is this one, very important, Hoffman and Curtis representation, and we can say Hoffman bromide thalamide reaction. So it is very important. Okay, I will show you. Second one is next one is very important. We can expect in our examination Hoffman bromide degradation. So sometimes he may just mention as a Hoffman reaction also. So here it is a functional group conversion reaction. So we start with amides, and we execute this reaction in presence of bromine, in presence of NaOH, or sometimes he mentioned as BRONA. Okay, so no problem. So we get NH2 and we may also get a carbon dioxide. Here see, so generally this product will be written as N plus C, and we end up with NC. So what happens, one carbon is less, so one carbon number is decreased. So that's why this reaction is also known as degradation. Degradation means, what is degradation? Cutting down or decreasing in number. So one carbon atom will be this one. This carbon atom will be converted into the carbon dioxide. Okay, so let's see the mechanism how it happens first. So first what happens, this Br2 will react with NaOH, and we may get this one BrONa plus HBr. Okay, so this is or you can also show like this also, NaOBr, no problem. Sodium borate, okay, uh, chlorate, sodium uh, bromate. Okay, and next step what happens, this amide RCONH2. So this lone pair of electron H, and see what happens, this is OH minus, this is base, this base will take up H plus ion, so removal of H plus takes places, thereby we get RC double bond O, N lone pair of electron, and here the minus charge, and here H. And then next step what happens, this negative charge will attack an bromine atom, so thereby bromination takes places, and we get C double bond O. So here lone pair of electron H and Br. So next step what happens, again one more base uh, comes into the play, and it takes up one H plus ion. So thereby again we get what, R C double bond O N minus, and this is Br, and here again what, lone pair of electron. And next what happens now, the Br will be eliminated as Br minus, so thereby this nitrogen will become electron deficient. So that means it lost one electron, so that's why it's supposed to acquire positive charge. Instead of positive charge, I am showing vacant orbital. Now it undergo rearrangement. Rearrangement means this lone minus negative charge attacks here, then this R minus alkyl part attacks on this vacant orbital. So thereby what happened, rearrangement taken place. So now this R will connect it to nitrogen, and now that single bond becomes a double bond, and this is what, cyanate, isocyanate, isocyanate. Generally this part is also known as ketene also, ketene, electron deficient species, that is ketene. Next, on hydrolysis of this isocyanates, the hydrolysis of isocyanate will give, so like this it happens, the two hydrogens comes here and oxygen goes there, so now it becomes RNH2, and that part will be converted as carbon dioxide. So this is the mechanism of Hoffman degradation. Okay, so here see, so this is about descriptive part, and this is the thing. So this is our amide. So in first step what happens, the base taken up one H plus ion, so it is reversible step, so thereby it takes one negative charge. So here he mentioned two lone pair of two electrons, the two electrons nothing but negative charge. So now one that lone pair, the negative charge attacks on one of bromine atom of bromine molecule, so thereby, so it will be eliminated as Br minus, and from here we eliminated H plus. Okay, next step what happened, again one more base will taken up one more hydrogen atom, so thereby again we get N minus, and this time what happens, this Br minus, due to electron density on nitrogen atom increased, so thereby due to higher electronegativity of bromide, it will take up the bond pair of electrons, so it will be eliminated as Br minus and leaving behind ketene. So ketene is nothing but nitrogen got positive charge, or else it's supposed to show a vacant orbital. So that means it become electron deficient. So immediately it undergo rearrangements. So due to rearrangement, what happens? This structure will take in place. I shown in directly like this. This is what isocyanate. And next one, hydrolysis on isocyanate, we get amines. So this is the mechanism how it happens. The base attacks on carbon. So here what happens, here we have one double bond, here we have one double bond, but this double bond migrated on oxygen. Why? Because oxygen more electronegative than nitrogen, so thereby we got OH. OH. Next what happens, so this is rearrangement taken place. So again what happened, this this negative charge shifts here. So that means actually what happens, here when it is attraction, this oxygen gets the negative charge. Now the negative charge comes here, then what happened, the resonance happens. Due to resonance, the nitrogen gets the negative charge, and what happens, now this bond shifts here, and this will be shifted here, so thereby we get like this carbon dioxide. So as a whole, at last what happens, the carbon dioxide molecule is removed, and we get ethylamine. So this is about Hoffman bromide degradation. Next one, reduction of nitriles to amines. Nitrile means cyanides and reduction, catalytic reduction. First we get imines, C double bond N is known as imine. It cannot be isolated. That means we cannot get from reaction mixture, and immediately these amines further undergo reduction, catalytic reduction, to give our final or desired product, that is amines. And here instead of here the catalyst, what catalyst can be used to execute this reaction, we have number of variety of catalyst. In that variety of catalyst we frequently use lithium aluminum hydride, that is LiAlH4, and second one is this is metal catalyst, nickel hydrogen or palladium graphite, or rainy nickel also, whatever it may be. Okay, so this is about reduction of nitrates and the reduction of cyanides. Okay, nitrates means nothing but cyanides. So again, dehydration, this is the second. One more thing is reduction of amides into the amines, amides into the amines. Next one, Schmidt reaction. It is also extension to the Huffman bromide reaction. Here what happens, this carboxylic acid reacts with hydrozoic acid. We know the NH3. NH3 is what? Ammonia, we know that. But here, Schmidt reaction. So Schmidt reaction. So in that Schmidt reaction, what happens? The carboxylic acids reacts with hydrozoic acid. This is hydrozoic acid. This is hydrozoic acid. So this is hydrozoic acid. Hydrozoic acid. So we know NH3, but it is reverse, N3H. N3H is what? Hydrozoic acid. So now this hydrozoic acid, first what happens? Reacts with the acid. So thereby what happens? Removal of water molecule takes place. Removal of water molecule takes place. Here this OH will be taken up H plus. So thereby we get this one. Double bond, N double bond, N plus, here double bond, N minus. Next, it may participate in resonance. It may participate in resonance. So we get RC double bond O. So this is N minus. The double bond becomes a single bond. So the nitrogen again retains a positive charge. That double bond becomes a triple bond. This is lone pair of electron. Next step, what happens? It will be eliminated like this. So thereby we get R C double bond O N minus, and here again vacant orbital. Why? Because here which one is removed? Nitrogen gas is removed. Again it may undergo rearrangement. What happens? This negative charge shifts here, then this will be attached to the vacant orbital of nitrogen. So now the bond is formed between alkyl part and nitrogen, and that single bond becomes a double bond, and C double bond. Again it is what? Isocyanate. And next, on hydrolysis, what we get? We get amines along with carbon dioxide. Instead of water, if you use alcohol, then we get secondary amine. Instead of water, if you use alcohol, then we get secondary amine. We get what? So here I'm showing. Okay, lack of space. Instead of water, if you use alcohol, then we get a secondary amine. Lone pair of electrons RH. Okay. So this is about Schmidt reaction. So this is nothing but extension from here onwards. This is same. From here onwards, it is similar to the Hoffman bromide degradation. Okay. So this is mechanism. Okay. So so far we have discussed about the classification and then preparation of amines. How we can prepare by alkylation of ammonia. Second one is this is alkylation of ammonia. Second one is Gabriel Thalamide synthesis. The specialty of this reaction is we can prepare only primary amines. And next second one is bromide Hoffman bromide reaction. Hoffman bromide reaction. So this is Hoffman bromide reaction, and then Schmidt reaction. Actually, we Schmidt reaction. After that only we have reduction of nitriles. Okay. So I hope you understood this. I will forward these notes into your group. Okay. So I hope you understood this. Thank you.